Now, moving on with the programmed schedule, we have an old colleague of mine, Gianluca Verin. Gianluca, can you display yourself?
I can.
Excellent.
Hi,
Here we go.
hello, everyone.
So, before I hand over to you, one of the big questions is Gianluca is well known to this community as the very first speaker on our very first episode of Uptime from Villa Grifone back in 2021. He's obviously the founder and CEO of Athanet before we sold to HPE. He loves 5G so much. He loves the pain so much that he decided to go and start another 5G company. So he's got some time here to tell you why he's doing it all over again and what new problems or what old problems he's found that he's got new solutions for. So with that, Gianluca, handing over to you.
And thank you, Nanda. Let me try to share a video. I mean, possibly I will not say a lot of things that are new because I heard the first the speaker before us, and actually very happy to have all this community. And thank you, Nanda, to bring us all together again. So starting with a very old picture for us, but this is still how private network can be used. We are looking at how we enable this in the future and how we are making it up. So this really is a very short video that shows how in a mission critical and actually destroyed almost environment, you have androids that can carry 5G networks and connects to other robots. Because we see this as being the future. I mean, we see that, not all the time humans will go to the rescue, but we'll have connectivity between robots and humans that are done by the bubble, the 5G bubbles that moves. This really is a short video that we wanted to show when we went to the critical communication world to show what we are about and why a private 5G network, if you compress it very much and is all autonomous, can do in different situations. So you actually see, we also went as far as bringing over an Android and to take it into a backpack. So this is really the type of future part of the story that we are working on. And you can see, many type of rescue scenario where we've seen and where we've been using this in the past. Fire brigades, of course, the capability to have a remote control and the capability of controlling these networks all over, plus some real work scenario that we did in the past and different places. So with this, actually, let me just stop this and go back to what I want to do, which is, let me switch. Oh. I will be able one day. Okay. Whoop. So let me show and share this. So we'll start all over again, and to understand with this how we came back and how we came to this vision. Now I have a disclaimer to do is like. When we talked with Nanda, he said to me, "Look, you should really try to do this from the Winter Olympics." So I try to do this my best. So I have some picture that kind of illustrate that we are like in the Winter Olympics, although I'm only in the mountains with some snow outside. So the title of this presentation is "Take a 5G Network with You," because we saying that at this time we are really being able to compress this system to this level. But now let's go back to the previous from scratch. So everyone now knows that in this audience that private 5G exists. It has been done. Some of us have been doing this for 10 years or more, even 20 years. And so I'm not really here to explain private 5G. I just want to talk about for a moment what happened when the network almost worked, and that's not good enough. So a national public network is set up. There is a major incident happens, Backhaul is degraded, power is unstable, multiple agency converge, data degrades, video drops. The real question there becomes who can still talk to whom and who will be able to take the decision. And this is really basically the space where we're trying to address. Let me go to the next. So here, I mean, apart from beautiful Cortina, you really look at how the private 5G network for government is done. So from the national coverage to federated bubbles, what you really need is to have coverage and the cover and basically give the right type of communication, which is voice, video, and data communication. Not necessarily in this order, because but you know that when there is a really little bandwidth available, then voice needs to still be there, arguably, as the last things to happen. Also in Cortina these days, this is what is happening. And here, basically, we all know that private 5G is really proven. But is operating a scale that becomes complex. National system, network optimized coverage and governance, but you really need the local responsiveness to have application run locally. So public safety doesn't really fail because technology is missing. It fails because the architecture sometimes doesn't operate the way that is supposed to be. And so that's basically some use cases that we actually see. So in use case number one, which one day I will learn how to get this one right, but in use case number one, we have a day-to-day national public safety network. You have police, fire brigades. You need to have an always coverage. You have mission critical voice, priority, lawful intercept. Is all there. Is a centralized and governed. In this case, network is not really under strain anymore. I mean, operators have learned how to do these things, even in places like in front of the Duomo in Milan, and this is where really the centralized network shine, if you want, and a private 5G, perhaps done as a private MVNO, as Vodafone was kind of showing before, is something that it makes a lot of sense. This gives us predictability, governance, accountability. We all know that these things work. Then you go to use case number two, and then you have large scale accidents that are large scale accidents, a major event. In this case, what you have is really natural disaster, partial infrastructure degradation. All these things you need to address somehow, and you need to address it with some local coordination. And if the architecture here assume that your core is always reachable, you may experience problem. So most public safety challenges are not really the blackouts. Are really the gray zone where things really are happening and there is a lot of strain, and then you have other type of use cases like this one that we're talking about, where you actually get critical public safety site like airport, ports, tunnel, and where sensitive data are very important, and safety is important. In this case, you always want to have local continuity and compliant with national governance. In this case, for example, we're showing what we did in Cortina for the Vigil Fuoco in Milan with the fire brigades, which basically have a system, a private 5G system that can switch on and off, and when is needed, if in case of emergency. In this case, you basically they all need the transportable system, and they need to basically use it when and if it's needed. But in this case, you don't want it doesn't want autonomy instead of the national network. You want autonomy in case the national network doesn't work. And then you have another use case that is actually even more extreme. And this basically is the deployable bubble type of things that we see this becoming very important. The deployable bubble basically is a place where you may have temporary accident or really far away. There is no fixed infrastructure, and you want to have a rapid deployable community. Here really is a picture that we used it because it was still quite a lot of snow and mountains. But it's actually in the Antarctica when we did the coverage with Starlink. And the point here is that deployable bubbles becomes the primary network for the mission, and is really the only things that will make this work. So the architecture that we like. The architecture that we like is a fully centralized architecture. Sorry, the fully centralized architecture will not really be able to suit all the needs that public safety has, and also thousands of isolated private core will not address everything, because if there is because to be truly mission critical, you can't really build on a classical national network. You build them If you build them in the same way, you kind of inherited the same weakness and problems, the fragility, the bottlenecks, and the failure and the stress. So mission critical architecture must be distributed, resilient, and designed differently from ground up, and we need them not to be just thousands of private core, but you need to have like a network of the networks, as we heard talking about it before. We really need to get them in sync and be able to communicate with each other, because you always need to be able to communicate one another in case of emergency for coordination and other cases. So I just came. I tried to be a little bit more technical, but just for a second, where you basically need to have the national public safety network should really be federated and be able to have an MVNO and possibly be able to act like an MVNO, and perhaps be able to connect to few operators at the same time, and at the same time be able to coordinate with dedicated side where really are dedicated side are needed, where deployable bubbles are important, like in the use case that we see, because the MVNO style kind of sovereign architecture that you see on top is really important for the national coverage, but you still need to address the use cases that are really very much local. Federation here is a choice and is not a dependency, so you really need to have all these dedicated bubble or site to be able to plug and play, let's say, into the network. So here's some of the voice and video and data, not single point of failure. Of course, you want to have a inter-bubble voice continuity. You want to be able to access remote application, and of course with AI when access is interesting. Central core and federated bubble with all distributed core. This is basically the type of architecture we see, and not single point of silence. I mean, you need to be able to address the points the requirements that the mission critical network needs. So what we do really at the end, and why we kind of came to this conclusion, really we decide to collapse kind of everything together: the sovereign edge, the tactical autonomy, making a radio core, a mission critical service all in one. This is shown into as you've seen it in the first video and this picture, where basically the federation allows the system and the people that connects to this 5G system to basically talk with each other. Going on, I mean, as we heard, the physical AI will happen at the edge, basically it will not break because the algorithm will be wrong. AI breaks because there is no connectivity. So we need to make sure that we are capable of bringing the radio for the AI, as I heard before, but the radio and the capability of the private network will be also an active system. It will be able, as we heard Maso, to be able to have application there at the edge and interact with the network and with the system. And so I think the physical AI and robotics will really start, and it will not even start. We believe if the connectivity, the way that it can do, if the connectivity is not there, if we do not allow with private networks to have a gigabit per second of throughput where is needed and when is needed. With this, Nanda, I think I
No,
finished.
excellent. No, thank you, Gianluca. That was really, really useful, really, really helpful. And it looks like you're focusing now on an end-to-end solution compared to just the core when you were at Afinet. I think what would be really interesting, given how long you've been in the industry, 20 years, well, longer, 25, that when you look at from 2020 to 2025, what would be, in fact, no, go back, we can even go back into the teens, right? Where LTE was taking off, and then suddenly everybody started talking about 5G. It kind of slowed the market down. And then now hopefully, if you can give some perspective on what do you think the 2 or 3 things that have been the bottlenecks for the market that you feel have been released for you to feel justified to go back into the 5G market?
So, Nanda, I don't know if you, I'm not really so much prepared to all these questions, to this question, but let me make it up now. And I think one important thing is people. And I mean, in this industry and this forum, I mean, everyone knows what private 5G is. When we started, there was not even a name for what we were doing. It was a core we didn't know. So, and the awareness takes time to come. And the fact that people now understand that locally, the local connectivity is important. And we had the wave of the edge computing coming, and we had the wave of mission critical communication. And now we have also the way of defense, if you want, where, things need to be talking with each other very much. And you have the AI now coming at the end. So what I'm saying is, of course, all these things were not there when we started, and I guess we were mad when we started the private 5G. We didn't even know that we were starting private 5G, to be honest. But the very important thing is that now there is awareness and there are use cases, and we know that that people really need it, and there is basically the need of connectivity at the edge. Obviously, having spectrum helps, and all the job that Mansour and other people have been doing this is very important, and of course the fact that we see the demand of connectivity growing with things at the edge. It is basically what really has made the difference. I mean, when we started with LTE, we were just amazed about that we were getting the first time 100 megabit per second into a base station from a base station. That was like the first amazing things that we've seen in 2012. But now, I mean, it's just normal. It's just so even technology has been coming with us, and the smartphone, era and all the data there at the edge. This has also been proven a very important factor.
Okay, excellent. We are about to move into the US era, and I think it's just appropriate that after you, the next speakers we have are from Druid, so it'll be quite interesting. But maybe before we go into America, just to close off the EMEA and Asia session, I'm just going to launch a small poll here, just to ask people, let's see, barriers to 5G deployments. So hopefully you can all see this. So, which of these has been the biggest barrier to the deployment of P5G networks from 2020 through to 2025, right? What is really going to change from all of this? So the first, we've got a range of options here. You only allowed one, and because we really just wanted to get people, if they had to choose one, what would it be? So all the way from lack of available spectrum is the first one, lack of access to radios, lack of access to devices. So what are the problems that we should be solving today? Complexity of the solution, and then the last one, affordability and ease of use. So if you have access to the poll, hopefully most of you have access to it. Love to get your feedback, and then we'll get our speakers' view on that as well. And then we can also get the view of the folks from Druid, who are the other veterans of the industry. I'll give it another minute or so. So why have these sort of things been chosen? So lack of available spectrum, as we know, we always had this rule as a business: follow the spectrum, because without the spectrum you can't deploy networks. Obviously, in much of the Western world now, you have spectrum available, and there's still new spectrum options coming up. But as we heard in the morning session out of Asia, in most of Asia, you haven't got private network spectrum available, and you have to work with MNOs, and the MNOs are saying themselves that they can't really allocate spectrum in urban areas because unlike markets where you've got fixed line, in most of emerging markets in Asia, the wireless network is actually the default form of communication. So there's literally no access to it. So spectrum in some parts of the world is still a challenge. Lack of access to radios and G-Node Bs. Of course, when we started in 2020, getting access to a G-Node B was really, really difficult. And you had the big players, then you had entrepreneurial players like Stephen, who used to oblige us. And I remember being on the phone to him, when is that shipment coming? When is that shipment coming? Waiting for parts coming from different parts of the world. It took a lot of time. Access to devices. Then once we got the radios, we used to run around trying to find a device that would connect to well, first of all, connect to a 5G network, and then to a P5G network. The number of times we had an iPhone 10 or iPhone 11 and trying to convert it and finding that it wouldn't support a private network. It took a long time until we found, and then we needed the ruggedized devices, etc. That took some time. Lack of access to devices that support P5G for your specific use case. So we heard earlier people talking about Ethernet PDUs, right? So if you want to do Ethernet over 5G, it's not just the infrastructure. You got to have devices that support that as well. We heard from ASCII this morning. We're talking about how you've got the wide support of devices now, looking at a wider range of use cases. Cost of the solution, I think that we heard that from Vodafone themselves. Demand is not the problem. It's trying to find a solution that is, from many players, I think the common theme was cost of the solution, complexity. We can't have solutions that cost millions. We need to get them down into the thousands, right? And then, of course, making it simple and easy to manage. So I'm going to end the poll here, and let's look at the results. Share results, sharing it over here. So the biggest thing, spectrum, and I think that kind of reflects on the discussion we had in the morning. In large parts of the world, spectrum is still very difficult to come by. The next thing is the cost of the solution. 30% of the respondents are looking at the cost of the solution as the biggest aspect. I think that's well known. We need to really bring it down if we need to increase adoption. And devices, okay, still a material issue for people, but we were on that topic. You're now seeing Zebra devices, you're seeing resilient form factor devices, people like Rug Gear, etc., who are making things for push to talk. So the ecosystem is growing. One question that comes up, and this is my own personal view, is people say, what happens when 6G comes along? There was almost a hiatus in private network deployments when 5G came along. Are we going to see that when 6G happens? And my answer very clearly is no, absolutely no. Because the real hiatus that happened was on spectrum, as it was pointed out here. So in 2020, when new spectrum was released for private 5G, it just so happened that it also happened to be the time that 5G was coming on stream. So most of this spectrum was licensed primarily for 5G, and device manufacturers who were going to manufacture devices didn't want to do it for LTE, wanted to do it for 5G. So we now have private spectrum, we now have devices on private spectrum. So to be honest, I don't think anyone's going to now hold up network deployments for the sake of 6G, because what we've seen is when you move to real production deployments, people actually want something that's reliable. A lot of our customers would have actually said, look, LTE is good enough for us. It's been around. We know how to use it. It's in every device. That's what we want to use. But unfortunately, the spectrum itself was mandated for 5G. So that was what really caused the hiccup in my view. And my personal view is that we're now through that, and now we're going to enter into the golden age of private 5G. That's my personal view. So let me stop sharing and move back to the main presentation. So we're now on track to have Druid join us. Mick, are you able? I know you're down in South Africa at Indaba. Let's see if you've been able to log in.
Yes.
Oh,
you should be.
There you are. Excellent.
You should be hearing me, and I've got some
and
material
here. We see you as well. So mining, obviously, one of the biggest sort of consumers of private 5G. So makes a lot of sense that you're down at Indaba, which is the biggest mining conference in the world, isn't it? Or something.
You better believe it. Yeah.
MWC of mining. Let's put it that way.
It is the Mobile World Congress of Mining. It's really it's very exciting down here. These guys, it's the mining industry is going through a digital transformation at the moment, and they're looking, and driven by objectives like efficiency, operational efficiency, but also safety is huge. And also environmental protection and environmental monitoring and reporting on those environmental protection metrics are big for this industry as well. Well, look, Nanda, I'm down here in Cape Town, and the sun is shining. I'm really dying to present this material and get out in the sunshine with a cold beer because it's been a very long day. But let me present, please.
Yeah. Over to you.
Okay, got it. Where am I? Okay, so I should be sharing, and let me see if I can get into presentation mode. Okay. You guys are seeing that? Everyone? Yeah, good. Nanda, that's good. You can see that.
Good.
Yeah,
all good.
All clear. Excellent. Look, I'm going to say Sawubona from Indaba. That's the only Swahili I know, but it actually is a word and it means hello from Cape Town. As you said earlier, we're at Indaba, which is all about mining in Africa. This mining is a phenomenally big industry here, and we are giving a message, and we are saying to the audience that private 5G, 4G, is the enabling sort of technology, for digital transformation in the mining industry. And as we said earlier, this digital transformation is widespread, and it includes very sort of human factors as well as business factors, such as safety and protection of the environment. But also, it's about operational efficiency, and it's about enabling remote remote sort of operation of mining equipment, which means people are out of the dangerous environment. It means protection for lone workers. It's just the data backbone network really is the enabler for all of this. So just a bit about Druid. I'm sure your audience have heard of us. We are an Irish registered privately held company. We're funded by business operations, so we have been profitable for the past 20 years. We've got a single external minority investor, and we see ourselves as a global leader of specialist core networking software for enterprise and industrial use. We're not new to this business. We've believe it or not, we're in this business about 20 years. We started off with we started off as a company developing technology for the big MNO suppliers, and then spun off our own sort of small core, and we eventually got more and more confidence and grew in capability to the company we are today. So we do serve the whole world. I mean, we've got big markets in Japan, big markets in Australia, India. I'm here in Africa this week, and Europe obviously is our home territory. The USA, I think, for CBRS networks, we're probably one of the leaders in the US. Building some market share and building some business now in South America. So we've yet to go down to Antarctica to see if we can build some business down there, but perhaps we won't. Who knows? But our solutions are, for enterprise. We have a real big focus on enterprise, and we develop our product, with a view that we want to offer, the very, very latest of 3GPP sort of features and standards that address real business problems. And I'm going to come on to that later in the presentation. But we also have our mocking platform, which is becoming more and more important, particularly, in territories where it's difficult to get spectrum. And I know you did your poll, and down here, the number one, question we get asked, day in, day out, in Africa is, how do I get access to spectrum? The MNOs are really jealously holding on to what they've paid a handsome fortune for, and they're not likely to give it up easily, is what I'm saying. So some way to cooperate with them is becoming essential if you want to deploy, private networks as opposed to just slicing, because I think, these industries, particularly the mining industry, want something that's in their complete control, that they have access so that they can integrate their applications, their worker applications, safety applications, autonomous vehicle applications with it. That's what they want. Giving them a slice doesn't really enable an awful lot of that level of integration. Also, Druid itself has MVNO platform. We do sell sort of discrete network functions as part of our MNO platform, but we're not here today to speak about that. One thing we do also is we do an awful lot of bespoke customization, for some of our larger customers. So we're certainly up for that. But getting back to, look, I'm sorry for focusing on mining, but we are here at Indaba. It's a huge industry, and it really is present across all of the continents of the world. So as I say, and this week, that's all I've been doing is speaking about mining and how 5G, 4G, private nets can actually deliver, operational effectiveness and better safety in these mines. So let me just go. Oh, sorry. So we're telling the audience here that a high-speed, secure mobile connectivity is the pillar, for digital transformation in the industry. It acts as a direct link to, real-time link to workers, machines, sensors, enable improved operational efficiency, safety, and sustainability metrics. And that's really the message we're saying, that guys, this is the wireless technology you should be using for the future. Now, there are some considerations here, right? The first one is Wi-Fi is very well established, but it's not addressing the emerging applications, particularly to do with autonomous vehicles and some other sort of real-time applications for such as required for TSN type apps for industrial automation. It's just not addressing that. Also, we have to keep in mind this is not the mining industry's first rodeo with respect to private cellular. The first one was deployed back in 2012, and we've got to understand that some of the first experiences, were not good. We've got to accept that. The feedback that we've been getting is hampered by over complex platforms and over complex management, and you know, and that, you know, we got to listen to what these people are saying. But, you know, incredibly, there's still a huge demand for, you know, for 5G, private 5G. So, you know, mining operations, you know, are switching from Wi-Fi to private 4G and 5G networks because, you know, the main issue is it can't deliver the reliability, coverage range, mobility, and security, right? For modern autonomous mining. You know, Wi-Fi is sufficient for, as we all know, for office-based tasks, perhaps, but in this harsh environment, right? You know, you require robust, high-performance network that's reliable. That, you know, when these big vehicles, the cats go by, and you know, will that actually change the radio plan and the radio reception that people are getting? You know, and you just need something that's very robust. And I think, you know, there is an absolute belief here, right, that in the industry that 5G and 4G and 5G, you know, it's not just 5G, it's absolutely 4G has a role to play here. So looking back on so what we're saying to the audience also is that the first private network, you know, was in Australia back in 2012 at Rio Tinto's iron ore mine, you know, but, you know, there is a new evolution, right? And that evolution, today's platforms are a better fit for enterprise, you know, scaled to meet the needs of standalone and distributed environments, right? What they were looking for is a complete unified platform. And that means absolutely complete, you know, 4G, 5G, you know, provisioning is included, right? And the KPIs and management platforms are also included. Like, it's all about sort of, you know, a self-contained, easy to manage, quickly deployed solution is what they're looking for. And, you know, this is what we feel that we are delivering, bringing to the party. Also, you know, you may think that a lot of these environments are, you know, they are out in the boonies, but still, you know, some of them have fiber networks. There's a lot of investment, you know, in this industry. So, you know, they can have, you know, fiber connectivity back into the sort of the business world, let's say, you know. But and so there are some cloud native requirements, right? People want to deploy, you know, in the cloud for some of their applications, but you got to be flexible because an awful lot of them still, you know, are data center and bare metal environments. And particularly, you know, we speak to people who, you know, still want the vehicular-based application for, particularly for where there's some new sites being explored and, you know, some measurements been taken and being feedback, data rather need to be sent back to home base for analysis. So also the features, I know you spoke about some of the features that are very interesting for the mining industry, right? Feature is easy integratable, you know, for enterprise telecoms and SCADA networks, right? You know, P25 or push to talk, incredibly important. 5G LAN is a real, you know, feature killer. I mean, that's absolutely what they're looking for here, you know. Also, to be able to, you know, connect Wi-Fi and, you know, non-3GPP access, radio access into your application is incredibly important, as is, in some cases, you know, satellite NTN access, direct-to-device access, also very important. But, you know, simplified, fast execution, and, you know, easy, low-cost operations, what these guys are after, you know. Sorry, just getting back onto the Druid theme, right? You know, so what we're delivering for these guys is a highly scalable platform. RAN is our platform name, and it does stand for Radio Emissary. It, in the old days, was more probably relevant than it is today, but we've stuck with the name. So it's, you know, and these are some of the key issues for this particular industry. And indeed, you know, the needs of the mines, they were actually exactly the same as they are for other heavy engineering, you know, deployments, such as, you know, port authorities and, you know, outside plant operations. So it's really, you know, very common across any of those sort of harsh, you know, outdoor applications. An awful lot of the applications and the needs are very similar. Again, I mentioned before, the flexibility to deploy in the cloud and to deploy on light platforms is really important for these guys. And multi-generational support. I mean, having 5G and 4G on the same core platform, and, you know, being able to connect on, you know, 4G radios and 5G radios, you know, where they're required locally, you know, it's a cost saving for these guys. And also, you know, where people have deployed 4G networks and want to migrate to 5G, being able to maintain 4G in some areas, in fact, it can be better, particularly, you know, if you got, you know, voice applications running, so, and really restrict 5G to certain areas, right? That seems a sensible way to do things. And, if you have a platform that can do that, these guys absolutely eat it up because of the investment they made in 4G. They really want to reuse that sort of RAN investment, particularly. What we're pitching is, that these guys kind of standalone distributed networks where you have a multiple sited infrastructure, but is managed from a central station, both from a user database perspective for provisioning and also for operational and KPI management and alarm and fault reporting. So that's in the centerpiece there. We also have a operator managed distributed sort of approach where it can become important, where spectrum is really at a premium, or it's just not available. I mean, we mentioned particularly in some of the African states, right, that they just don't want to hear, right, the argument for private spectrum, for private networks being built. So you've got to work with the guys who have the spectrum, right, and you've got to, get them on board and either, deploy through them, to the end user, or cut some sort of deal with them. So, and that's really quite common down here. So on the right hand side of the slide, we have a solution where operators can get into the business of deploying discrete private networks, for specific customers. This is as distinct from a slice. This is a complete private network, right themselves. So that's becoming, a thing. I'm not saying it's completely successful yet, but it's becoming a thing, right? Let's say. This is our platform. This is what we supply. I mean, we have best way to describe this is it's a 4 and 5G platform. It's got all the elements of network functions of 4G and network function 5G together with Wi-Fi access elements, and it's all sort of concentrated on a common data plane, and we break it out from there, and also have an INS on board. So very easy to deploy, and as I mentioned before, the multi-tenant roaming applications also available as our NTN TSN applications already. I think look, I think that's where I've left it now. So I'm not sure if there's a facility for people feeling questions, but I'm happy to answer questions. I'm happy to answer questions from you.
You're right. Thanks, Mick. We've been saving up quite a few questions for you, actually.
Good. Excellent.
All the way through from the morning, and I think Dean won't let me go unless I bring up his question, which I think he raised in the very first talk this morning, which is how will eSIMs change deployments of private networks?
Well, will it change the deployments? I think they're just going to make things an awful lot easier, right? Because it makes the device multi-carrier device, so you can have both public, private, and multiple public or multiple privates and networks being supported, or that being a in the HSS of multiple networks. I think it's an awful lot of these particularly for the sort of the router applications where people are either using private networks on a permanent basis but want public networks as a fallback alternative. You often see that, and for some of our security, that's civil security, police forces, we see an awful lot of that they're using private networks, but they do want either one or multiple public network support, and they have multiple eSIM devices deployed. So I think it's a real enabler, and we love to hear, but we think that is a big enabler for us for the future. I think it makes life very easy for a single device and single sort of UE device. Absolutely all on for it.
Right. It'll be interesting also to get your view, Mick, as one of the longest players in the industry. When you look
Thank you for not using the word oldest.
I meant
no, you're okay.
In a corporate sense, not in a
Yeah.
not in a personal sense. Although I think 5G has made us all look a lot older than we are.
Perhaps.
So, but if you think of 2020 when Spectrum first became available to 5,000 networks today, that's below I think what people sort of expected, and there have been roadblocks, right? And many of them have kind of disappeared. We just love to get your sense in terms of what you saw as the main sort of roadblocks over the last 5 years in terms of rolling out 5G and how that's changed and for the future.
Well, I think
are we entering the golden age?
There's no doubt, and there's no doubt it's all about, for me, it's all about, spectrum allocation. And it's and in Africa at the moment, there's you can feel the upswell of demand for for private networks, both 4 and 5G, and you can see there sort of punch shoulders when they you talk about the spectrum again. Even the operators, we really need to get to the regulators, and they need to understand that making provision for private networks, right, is an industrial enabler for advancement, and innovation. And that's what we really, I mean, it's not, I mean, they've done it in the US, they've done it in Europe and Japan it's been gone forever in Japan as far as I can see. But I mean, it's really allowed people to, use a private 5G or high-speed broadband connectivity for a lot of reasons. And port automation is one, and but it's about, I think, industrial advancement. It's about industrial innovation, because we know that the operators, like, I mean, I have to say, I gave a presentation recently on, on operators versus private networks. I mean, the operators really have their hands full. The over-the-top guys are just on a free ride with them, and the poor operators are left having to fund all of the infrastructure, right? And they're getting revenue from their customers, but they're not getting a fair share, I think, of their. And I actually firmly believe that, of the revenue. So it's a rough ride for the operators at the moment. If you try and ask them to consider specific applications within industry, they just can't afford to take it on. And here are groups like ourselves. We're biting at the bit to get loose at these things. If we just got a bit of spectrum, we can actually make industry a lot happier, enable it to be more efficient, enable it to be more innovative, and create more jobs. And that's what we could do if we were let.
Yeah. And are you meeting with, while you're in Africa, are you meeting with any regulators or people from government?
Well, I mean, what we're doing is we're
private spectrum.
No, well, we are meeting, trying to assist the lobbyists, right? Just making the arguments, speaking about our experiences in Japan, speaking about our experience in the US, speaking about Europe, and saying these are the type of things that can be enabled if more spectrum is available, and to us. More, I mean, we're not looking for an awful lot, as you well know. We don't need it, but it's what happened in the US, I think, was very, very positive, and Japan as well. So yeah, working with the lobbyists is what we're doing, not the actual regulators themselves.
Okay, but if you could have three so leaving spectrum aside, because clearly that's the biggest item on the wish list for everybody. But if you leave that aside, if we, one of the themes that we're having today is to go from 5,000 to 500,000 networks by the end of the decade. If there were two other things that you could choose in terms of allowing the market to explode, what would it be?
I think that the next thing, and I think it's a generally accepted view within the industry, I've spoken to a lot of people about this, is the skill sets that are available. I think one of the guys, and I have to agree with him, he stood up today and he was saying, look, even if we have the spectrum, I said we have an absolute debt of skill sets of people who understand radio, who can deploy. It's just that skill set is completely, I think, needs addressing at the moment. And the education facilities, I think we perhaps should be bringing them on. Perhaps we should be working more with them. And even Druid, we're thinking about doing some sort of cooperatives to help emerging markets by having sort of students come up and to Dublin and work with the developers. But I think the skills are big. There's a big sort of a gap there that we've got to sort of address as well. And I think we've got to be innovative about that, working with universities and education facilities to do that. I mean, perhaps. I often think that everyone doesn't have to, do an MSc or PhD. They can, there can be other sort of basic skills. I think I taught at industrial school level and to get people well up to speed. It's about using the tools because with AI out there at the moment, it's just about using the tools properly and training them to use the tools. So I think it can be done quite quickly.
Yeah, but one of the challenges that we used to always find, at least I found, when we meet a client and you told them on the idea and you wanted to move even towards a POC, was the first roadblock you actually had is when it came to designing the network. The network design was okay, but the radio plan, right?
Yeah.
And that's where, if you look in Wi-Fi, they've got Ikahu, or they've got all these easy kind of solutions. But in our industry, that's the very first thing. So it's almost as if we've made the core easy. Radios here are all easy and stuff. But the gating factor, which is just doing something simple as a radio plan, seems to be a gargantuan task. Any thoughts on that? Any?
Well, I firmly believe. I mean, I've done a few in my day, and I firmly believe that they're not as difficult as it seems. It's not a black art, and I think there are tools that can be used, and the tools can be improved. So, as I say, I think it's about teaching people to use the tools that are available, and perhaps refining and developing better tools. I think it's just the real challenge is what can we do as an industry group, as an interest group, to actually enable that. And it would be nice to have a common sort of thread through what people are doing, and pressure, lobbying the educational authorities, or maybe even developing an apprenticeship programs ourselves. I don't know what, but something like that I think could be done.
Right. No thoughts of adding into the Ramus suite a radio simple radio planning tool?
No, believe it or not, we have done that. Actually, we have already a walk test that you do, and you ping and it maps and gives you a reading at various levels. So yeah, no, we do, and as I say, that's like a really good example of tools that can be developed to actually help this and help the gap in the skill sets, I think.
Excellent. Okay, well, no, thank you very much, Mick. So we're going to leave there with a thought that from Mick, that Spectrum, if he had one thing, if he had a silver bullet that he could use, it would have Spectrum written on that silver bullet. Meanwhile, we'll let him get back to mining for silver at the Indaba.
Okay, thank you very much, all. Thanks, guys. Cheers. Yeah. Ciao.
Excellent. Super. So our next topic is actually going to be Spectrum with and the RAN with Tamer from Globalstar. But before we do that, we're at the halfway point of the day, and we've had quite a few sessions around. So probably time to do another interesting webinar. Let's do a poll. So I'm going to start this one off with, how many private 5G networks do you think we can realistically deploy in the next decade? Can we go in the next decade? That is. So my wish is, my North Star is 500,000. Let's see where our audience looks at. And lots of interesting questions that people raise, because, would you rather have one nationwide network for rail or emergency services, or lots of small networks for consumer uses, etc.? And I know there are lots of permutations and combinations that we can look at, but us humans are simple. We like volume. It's an easy metric. It's an easy KPI. So let's stick with that one for the moment and see where we get to. There's a little sort of race that's going on between the 100,000 marker and the 100,000 marker is in the lead. Maybe it's going to get the downhill ski championship this year at Cortina. Let's see where we're getting off to. And Actually, I think we've got quite an optimistic group today, because if I add the 250,000 and the 500,000 together, they're probably in the lead. Okay, I'll give it another 30 seconds before we end the poll. I'm not seeing any more changes here. Okay, so I'm going to end it now, and we'll share the results. So if we look at this, 100,000 is the mode. But if we look at the skew, I think 250,000 and 500,000 add up to about 47%, and then 37% is the 100,000. So we got well over 80%, 84%, looking at 100,000 or more networks. I think that's quite bullish for the future. So the excitement levels are very high. So with that rampant belief in private 5G, I'm going to ask Tamer from Globalstar to reveal himself.
Hey guys, do you hear me?
Yep, excellent. There you are, Tamer.
Okay, great. You guys see me also, I assume.
Okay, super. So Tamer, I don't know how much you caught of that survey beforehand. We seem to have a very optimistic audience. And before that, it's a good handover to you, because we had the Druid guys from Africa talking about how the biggest issue that they're seeing, like mining, a huge use case, but in Africa there's no spectrum, and in many parts of the world there's no spectrum. You would probably have missed the Asia session this morning, where again, huge demand for private networks, but no spectrum. Now, with all of that, I'm going to introduce you as the guy with all the spectrum and also a RAN solution. So with that, please take the floor.
Yeah, actually, I just happened to hear the last presentation. It's too early here for me. But there were multiple points that I want to touch on for sure. So let me project. Okay, so you guys see the slide?
Yeah, we see it.
Okay, great. So I want to cover mostly 3 main items in this presentation. One is to present the solution, the RAN solution that we have, XCOM RAN, and the motives that drove us to build it in the first place. Then the spectrum, as you mentioned, that we have and propose for private networks, and especially in Africa, actually, or at least we have very good presence in Africa. And then the last part of the presentation is a case study that we did on warehouse. Actually, we didn't do API research did. We provided some information there, which just show the benefits of going into something like private network and specifically XCOM RAN on the industry. So first, who are we? XCOM RAN is a product of a company, a startup called XCOM Labs, that was founded towards 2018 by ex-executives of Qualcomm. Most of us came from Qualcomm. We worked on this technology. I would say we proved it first as a concept up till 2020, maybe, but we worked on it for 5G and building a product for it in 2021. And we have been selling and developing more features and stuff since then. The company got acquired by Globalstar, at least the XCOM RAN solution got acquired by Globalstar in 2023, and the founder of XCOM Labs became the CEO of Globalstar, Dr. Paul Jacobs, who is also before the ex-CEO of Qualcomm. And as I said, most of us came from Qualcomm, so there is a very strong DNA of wireless over the years. Now, Globalstar, in its itself has been a satellite operator and provider for IoT. So by acquisition of XCOM Labs, they built a private network solution business unit. And the reason for that is that they own spectrum. They have been owning spectrum since 2013, which became 3GPP compliant in 2016 and has not been utilized. So our mission in XCOM RAN has been to try to jump on this industry 4.0 and provide the connectivity part of it and try to do it in a way that enable solutions. And the point here was to understand the limitations of deployment. Some of them Michael from Druid pointed to, and solve these problems and solve them in a sense fundamentally in the architecture from the beginning. And by the way, we started at least mostly as a RAN solution. So it's the innovation that we provided is really in the RAN, and it's, as you'll see, a bit different than the typical deployment of RAN. Then after that, we migrated to different aspects until we are now at a point where we have end-to-end from the radio all the way to the core network. Now, what were the challenges that we thought are kind of hindering the big hype and the big promise of 5G? Well, over the years, we find out that the solutions for private networks have an element of bespoke in them, have an element of every solution, every problem have something different in the solution. So it's not like one solution fits all use cases. And the ROI becomes harder this way because you cannot continue to build solutions with different features here and there, especially with the size of the market that has been growing, but not at the expectation of the whole industry. In many use cases and applications, there are a lot of dynamics in it, a lot of moving parts, and that effectively in communication system changes the environment. It changes if you deploy multiple cells, it changes the definition of the boundary of a cell. It changes the demarcations between cells. You add this with the quality of service that is required, it becomes really challenging problem. Now the automation in general as an industry and the way 4.0 works, industry 4.0 works, is that there is a lot of efficiency required. In warehouses, for example, the ASRS system, the system that is responsible for delivering orders, they have a very strict requirement on how many minutes it takes from the time you get the order to the time you execute on the order. And that applies almost in every single industry, especially the new industries, the industries that are built over AI. It requires a lot of efficiency, and that requires a lot of information coming from sensors, which becomes very heavy uplink. So there is an important need for the capacity part of it, as I said, especially in the uplink. There is also some mismatch in the way most of these enterprises are used to deploy a network, which is they're mostly used to Wi-Fi, which is an L2 based system, and 5G or cellular for this matter, which is mostly an L3 IP based network. So how do you make the solution look like the Wi-Fi? And that's something that has been recognized by many companies working on this. And finally, actually, if you put all of this together, you add to that the problem of the spectrum, that what spectrum to use. In many countries, there are shared spectrum. The process is not easy, especially in the United States. Actually, CBRS has not been the easiest thing with the SAS in the process. But spectrum have also been one of the main reasons why you go and deploy a solution, and then you find that you have these constraints. Of course, the size of the spectrum, like as in the bandwidth, is not the same whatsoever between what Wi-Fi has and what 5G has. So what do we have? I'll actually focus on two things, the first two things here. The private network solution that we have, which we call XCOM RAN, and the spectrum part that we have. There is actually in Globalstar a third part, which is the satellite link, which can be used as a part of a full solution, especially for ports and things like that, for tracking assets and maybe more applications, like you can have an end-to-end solution with the satellite component in it. But I'm not going to touch on this in this meeting. So XCOM RAN, to understand what the deployment really, how it works is you have an area and you put radius to cover the area, or you put radius, I wouldn't say to cover the area, but you just put radius, and it's an ORAN based solution. So all these radios get to be connected to some kind of an edge compute, which mostly run the stack. And it also runs the core network and the management network as well. But all the radios are connected to a single edge compute, and the stack run on this edge compute. So in a sense, the stack can run in a way that is joined across all radios. It's a bit computationally heavy, but compute, of course, is not a big deal, especially with the size of computes that are happening now in AI. This is a very reasonable compute, but with compute, you can execute on, or you can jointly run the stack for all these radios. And if you do this, you provide a form of a dome of coverage and capacity, as in the radius demarcation became irrelevant to the user. Like the device, the UE, does not see multiple radios, it only sees a single radio. And every time you add a radio, it actually improves the performance of the system. So all these radios will be serving every single device. Of course, in some cases, the device may be close to some radios, not the others. But in general, every radio is sending information to this device. And if you look at this structure, it has a lot of benefits in deployment of a wireless network. First of all, if you need more capacity, you add radios, because this is not just radios added for coverage as a dash system. These radios are fully functional. Every radio you add provides a full capacity of a cell by adding it. So you need more capacity, you add more radios, and in this case, you are adding more radios not for coverage, but for capacity. You are densifying the network. That, in a sense, remove the capacity limitation, because you can get the capacity not from the bandwidth, but from adding more radios. And as long as they run as a single big radio, which we call supercell, single big kind of a single big super radio kind of. So that's on the capacity side. The other thing is that because all the radios serve every single user, there is naturally redundancy in this. Something goes wrong, radios go down, and the radios also overlap. By nature, they overlap. I mean, you can deploy them for coverage at the edge of coverage of each radio, but you can allow them to overlap to get more capacity, as I said. And because the system allows and benefits from overlapping, it doesn't have a concept of RF planning or radio planning or anything like that the gentleman Michael brought up as one of the challenges, because really there are no demarcations between these radios. So it looks like a full coverage kind of a network that has also it has the capacity and has the coverage and has the redundancy in it. And then the fact that the stack run on an edge compute allows you also to be very close to the application. So the application can run on the same compute, and you can expose. That takes me back to this bespoke thing. In some application, you may want to expose some of the wireless metrics to a lower level. You can expose it to the application and provide better performance on the application. And because the stack is running on a compute, it's one software release away from any features needed by the customer. So it gives you flexibility in deployment. So the takeaway of this is that the way of this deployment is remove the boundaries between the cells. It's actually look to the device as a single cell. You can increase capacity by adding radios. You can increase coverage by adding radios. It provides a more flexible solution. And then add all of this, that these radios can be, of course, they're spectrum agnostic. They can be on any spectrum. But also we have this N53 that I'll touch on later, which is a 3GPP spectrum. So N53 is the name of the spectrum in 3GPP. It's only 10 megahertz on the 2.48 to 2.49. In some places, it's around 16 megahertz. So these radios also support N53 as one of the spectrums that are provided. Altogether, we feel this solution is a self-contained solution that can remove many of the obstacles of running private networks for Windows. This is just one slide on the partners. The core, we have integrated the core with many providers. Druid actually has been the main provider so far, but we did also with HPE, Ethernet, and the rest here. We also have our own core. It's called X-Core. We don't use it in, we mostly use it with N53. Compute, we have been using Dell and Supermicro. Anyway, the devices side, actually, the important part of it is for N53. So I've been increasing the ecosystem for N53 devices because one of the problems of 5G I see is devices in general supporting 5G. But 53 is an additional challenge in a sense because it's not very commonly known spectrum so far. Okay, so back to what is 53. So 53, this 10 megahertz, which is between 2483.5 to 2495, this part of the spectrum has been used by Globalstar as part of the satellite links. But in 2013, they got the authorization from ITU to use it terrestrially, which means use it on the ground. And by nature of the satellite networks, this authorization applies globally in any place in the world. But you take the authorization and regulatory body by regulatory body, you get the approval, you try to get the approval to run private networks on this spectrum on the country. As of now, it is supported in 13 countries. 7 of them are in Africa, actually, and the mining industry is very important for us because of that. So 7 of these countries are in Africa. There is a power limitation in the countries outside Africa. Actually, in Africa, there is no power limitation in the most part. But in countries outside Africa, there are limitation in the power you can provide to 36 dBm, which is like 4 watt. So that's why it's more suitable for private network as for ubiquitous coverage MNO network. And the bandwidth is only 10 megahertz. So it depends. The application you can use in general will not be very high capacity kind of application, except that when we add XCOM RAN to this spectrum, we can get like very reasonably, you can get 200 megabit per second from it. So there are many applications that can still fall into this category, like can make use of this spectrum. It's also in the United States, in Canada, in Mexico, in Brazil. In Europe, unfortunately, it's only in Spain. We are trying to focus on this now to increase our presence in Europe. So I covered what the technology is, what the band is. This is a case study on using private network, actually mostly using XCOM RAN in this case, for a warehouse use case, which is deploying automation in the warehouse. I'm sure most of you are familiar with some of these systems, like the ASRS system. And they use AGVs, they use vehicles that are automated. And the wireless, of course, is very important here. The de facto solution that they go to usually in this industry is Wi-Fi until they find it's very challenging. So this particular use case was done by ABI research, and it was trying to quantify the cost of inaction of a technology like this and the return on this investment over time. The case study was 220,000 square feet, assuming 120 employees working, and again looked at some statistics on the financials of this thing. So the report, by the way, is can be found on ABI research, but we can provide it as well, and probably I'll give Nanda a link to it if anybody is interested. But these are some of the benefits that in year 6 you can make in this particular example that we modeled, like 1.1 million, you can get 5x return after 6 years. You almost break even in the second year. If you look year over year, there are many statistics on the improvement of doing a private network versus any other solution in this. I'll just take the first 2 metrics in these 2 categories, 35% more packages and 20% less downtime. Downtime here is huge. It has really huge benefit for these industries. Like some of this stuff you cannot quantify, like how do you map the downtime to money? Probably it's not the most straightforward thing, but downtime in system like that, which usually run as 4 nines or 5 nines, is a big thing. Because as I said in the beginning of this presentation, it is judged or it is measured by how long it takes you to deliver an order, and 10 minutes, 12 minutes, something like that. So any downtime becomes really an issue. So just to summarize what I presented on these two things, I presented the solution, the RAN solution, which is again a RAN innovation that's a bit different from the small cell deployment that are typically deployed with boundaries and RF planning and handover boundaries, I mean, and RF planning and interference between the cells. And I presented the spectrum. We deployed this approach in, like I would say, the biggest customer so far is a global retailer, and we do this in the warehouses of the retailer. And there are two actually opportunities for private networks there. One in the bigger warehouses, which they call the distribution centers, and one in the stores themselves. Been working with a number of system integrators. If you guys are following us on LinkedIn, you will see a number of press releases coming out. But we are, in general, we're trying to use these two assets to either enable new technologies or use this efficiency of deployment to have a more cost-effective, maybe more efficient solution for other deployments or for other use cases. We'll try to provide a good business value, return on investment on the solution. Of course, many challenges in the way. I would say that the solution is in a very mature state now and has been commercial for almost a year as of now. I would stop here and happy to answer any question.
Thank you, Tamer. So I guess one of the questions that comes out from this morning's session was all the deployments that we're hearing out of countries like, big, massive countries, India, Indonesia, Philippines, Thailand, Vietnam, big sort of manufacturing bases, lack of spectrum, but huge demand that they see for private 5G. In the 13 countries that you've got, if I recall, Asia is not there, or where is Asia in your plans?
Yeah, no, actually, there is no single country in Asia as far as I remember in the 13 countries, right? Because there are North America, South America, and Africa have been most of the, I say 12 countries in this region and one country in Europe as of now. See, the process to go and get regulatory permission to use it for private network is kind of a paper process and some fees. So we can, in theory, we can, as long as the spectrum is not used by the country, we can use it. And most of the places, as I said, because it's originally a satellite spectrum, it shouldn't be used. But I wouldn't say that this is a point blank that in any place we can get it to be used.
Sure, very good. And you talked about some of the deployments that you have in the US already, and I saw a public announcement just a couple of days ago that you're doing something with Boingo, and Derek Peterson, CTO of Boingo, is speaking later.
Yeah.
So we'll have a chance there as well. Anything you can share on that?
Yeah, it's a very, very interesting use case, actually. It's and I know Derek has a talk right after me, or probably close to. It's a very interesting use case because those systems are very popular systems, and they are deployed in the United States a lot. And of course, Boingo is one of the major players there. And in that system, you get a lot of benefits, like you get homogeneity in performance, you get coverage. You don't necessarily get capacity because at the end of the day, the network is a single said, you can get capacity by bandwidth, but not by radius. The antennas are transmitting the same information. And then what we worked with Boeing on was the clever idea by which you use the infrastructure of the DAS as is, but you feed an XCOM RAN to this infrastructure. So you run a private network on the infrastructure of the DAS. So now the antennas are not necessarily transmitting, I mean, for this part of the bandwidth, for this part of the spectrum that we do the private network on, you are actually getting not necessarily that all the antennas are transmitting the same things. You get capacity benefit of it. So it's kind of an overlay, kind of a second layer or one of the layers. Use the infrastructure for DAS for coverage, then you put a private network over some bandwidth, CBRS or N53, as I said, that provide a capacity factor in addition to the benefits of the DAS. In a nutshell, that's what we are doing there.
Excellent. And you mentioned logistics, for example, and warehouses as one of the examples that you brought out earlier that you did with ABI Research. What are the verticals that you're targeting mainly in these 13 markets? And what was it that drove you to pick these 13 markets rather than the USA is obvious, right? But
yeah.
Yeah.
Well, actually, let me clarify. It didn't come this way. It's not like we licensed the spectrum in the countries we wanted to work on. Because remember, Globalstar actually licensed the spectrum in 2013. They started from 2016. They have been starting this process, or maybe actually 2013. I think they did not go about it with a clear business drive. Like I'm gonna do it in this country because I have this or that. They didn't have actually private network at that time. They didn't have XCOM RAN or anything at that time. But I think some countries were obvious, like Canada, United States, were kind of obvious. And some countries were easier. Like Africa, I guess, were easier. So they were able to get it in 7 countries in Africa. And the business in Africa is kind of different from the business in United States. So the business in United States is focusing on, again, enabling applications that are high end. In Africa, because of the mining opportunity, it made sense. But there wasn't really an underlying solution or end-to-end solution at that time. With us, we came and found out that, okay, so we have this kind of assets on all these countries. How can we tailor the technology to different use cases that can feed to this? So in the most part, we try to be enabler solution, as in we try to make an application workable with private 5G, of course, workable with wireless, I would say. And that's why we focused on things like automation and industry. However, the 2 important points here, we run into use cases that are not necessarily very high-end enabler, like we enable them all. It's just that the efficiency of deployment can help in multiple aspects in the economics of it and in the performance, like as we said, for example, how you deploy. The second thing is that when we build the technology, it wasn't just for N53. We build it's spectrum agnostic. So, for example, for Europe, there is a great demand for N78. Like most of the deployment I see there are N78, either in the shared spectrum, which is partially coming from N78, or even if you were to license, like to lease spectrum, it's also N78. So in Europe, we have been mostly working with N78 and trying to provide N78 solutions. So again, on the application side, we shine really when it is and something that we can enable, but we shine in another way if we do it efficiently, even for the applications that are not necessarily very demanding. On the spectrum, it can be any spectrum, but N53 was chosen before we came. So we chose the application that fits the region in a sense, which is partially, I think the demarcation, as I said, in Africa, it's mostly mining. Outside the world is mostly things like automation and industry.
Right. Okay. And lastly, before we close off, let me just see if there's any questions from the audience. Yeah. So devices clearly are the most important and important part of the of any ecosystem, and whatever we do on the infrastructure side without the devices, it doesn't really go forward. The good news is that N53, for example, is in every single Apple since iPhone 15, at least since iPhone 14. This one certainly has it. Could you talk a little bit about Android? Because I think a lot of people in private networks are probably using a lot of Android solutions, so it'll be useful.
Yeah. So the devices have been a problem. I think it's one of the challenges, like you asked the previous speaker on the challenges. I think one of the challenges is devices that support 5G in general, especially when you get to application like cameras, like not necessarily devices as in phones, but in industry. If you look at the IoT sensors, Wi-Fi is kind of a default, and 5G is not necessarily the case. So in general, it's a reason. It's a big challenge to devices. But N53, as I said, the situation with N53 is it is part of the chipset. So the biggest chipset manufacturers like Qualcomm, MediaTek, they have it already. They have N53 as a part of the chipset. The device not necessarily have it because the device does not certify. So any device manufacturer, any of the people who build device, they go and take this spectrum. They go and take the chipset and they go certify for the different bands. So in absence of clear use cases or ecosystem for N53, they don't necessarily care about N53. Now iPhone, it came in iPhone 14 because of other reasons, because of the satellite link really, and it became after that a de facto for N53. Now that has been changing actually. Zebra, by the way, Zebra is a very, very important device manufacturer in industry. They have announced N53, I would say maybe a month, 2 months ago in their tablets. But if you go to Android specifically, again, I'm not aware of a phone that supports N53 that is Android, but it is actually in the chipset itself. So if you build a device, like if, for example, if you take a Telet module or a QTEL module, all of this has N53 and certified, and you build a device that's Android device on them based on these, then you'll get it automatically. But something like phones like Samsung, I'm not aware of something that support N53 naturally unless you work with them.
Sure. Okay. Excellent. Well, thank you, Tamer. I think that's been very illuminating. You've addressed, two of the crucial points in private 5G. One, spectrum, and the second is how can we get more capacity? Actual usable capacity with a high information ratio out into people's phones. So thank you. And so from uptime, we'll let you have some downtime now and continue the discussion at MWC.
Yep.